So another very confusing topic is what is two-tailed test and what is one-tailed test, and what are the various scenarios where we have to use it. So let's try to simplify it, and here I have drawn the three bell curves and I cannot draw them more accurately. So two-tailed test. So for two-tailed test, first of all we have to recall our old knowledge that at 95% confidence level, at 95% confidence level, our alpha, and what is our alpha? Alpha is type 1 error when the null hypothesis was true, but somehow it was, when the true null hypothesis was rejected, it was type 1 error. So at the 95% confidence level, the alpha is 5%, and this is the reason that our significant p-value is always 0.05, and we say that it is less than or equal to 0.05 p-value, that is our probability value, we say that it is significant. So now at the 95% confidence level, when we are accepting our true null hypothesis in 95% of the cases, the rejection area, now these two are the rejection areas, they are equally divided on two sides. So this is the rejection area, this is the rejection area, and this is the 95% confidence level area, where we know that the population mean, that is mu, is somewhere between this, and our sample mean obviously is x bar. So here is the rejection area, here is the rejection area, half is here, it is the negative side, half is here, it is the positive side. And our critical values at 95% confidence level, our critical values, which are also called the z-scores, we all know from the standardized tables that it is 1.96 positive here and 1.96 negative here. So at 95% confidence level, our type 1 error, which is also called the level of significance, is 5%. So this is 0.95, and 5% is half here, 0.025 is here, 0.025 is here. So obviously now at the 95% confidence level, with the predetermined level of significance of 5%, our rejection areas, that 5% chance, there is 5% chance that the true null hypothesis will be rejected, is equally divided on both sides. So obviously when the two tails are using, that's why here we will use the two-tailed test. Now what is the one-tailed test, and where to use the one-tailed test? The one-tailed test can be on the left side, the one-tailed test can be on the right side, and basically the one-tailed test is related to now alternate hypothesis. Now we will try to understand it with an example. Say for example, our null hypothesis say that, as we know that population mean is mu, but as the population mean is usually not available, we use x bar, that is the sample mean. Say for example, our null hypothesis is that mu is 12. We are just taking an example that the null hypothesis is saying that mu is equal to 12. But alternate hypothesis is saying that, what is the alternate hypothesis? Alternate hypothesis is saying that mu, the population mean, is not equal to 12. So when the alternate hypothesis is saying that it is not equal to 12, obviously it will say that whether it is, what are the two options? Either it will be more than 12 or it will be less than 12. So when in the alternate hypothesis, when the alternate hypothesis is saying that mu is more than 12, when it is saying that the value is more than the value of the null hypothesis, then the rejection area more than positive here, then the rejection area will always on the right side here. The rejection area will be here on the right side, and still we are working at 95% confidence level. So this is the 95% now. This is all now the acceptance area, and the 5% rejection area is here on the right side. And when our alternate hypothesis say that the mu is less than 12. When it is say it is less than 12, less than the value of the null hypothesis, then our rejection area will be on the left side, negative area, left side. So here is the rejection area. Rejection area will be here, 95%. Acceptance area or the area which will not be rejected. The probability 95% that a true null hypothesis will not be rejected, but the 5% rejection area is here. Then the alternate hypothesis saying that mu is less than the value of the null hypothesis. So then it will be on the left side, more than the value of the null hypothesis. The rejection area will be on the right side. So obviously in both these scenarios, the one tail test will be used, as we are using only the one tail here and the one tail here. And another very important thing, that in both these scenarios, now the critical value will be 1.65.